Television. The device we call the television is really a television receiver that is the endpoint of a broadcast system that starts with a television camera or transmitter and requires a complicated network of broadcast transmitters using ground-based towers, cables and satellites to deliver the original picture to our living rooms. In 1928, Philo Farnsworth made the world's first working television system. The basic idea of television is radio with pictures. Television is really a three-part invention: the TV camera that turns a picture and sound into a signal, the TV transmitter that sends the signal through the air, and the TV receiver that captures the signal and turns it back into picture and sound. TV creates moving pictures by repeatedly capturing still pictures and presenting these frames to your eyes so quickly that they seem to be moving. Almost all TVs in use today rely on a device known as the cathode ray tube or CRT to display their images. An antenna on your roof picks up radio waves from the transmitter. With satellite TV, the signals come from a satellite dish mounted on your wall or roof. With cable TV, the signal comes to you via an underground cable. The incoming signal feeds into the antenna socket on the back of the TV. The incoming signal is carrying the picture and sound for more than one station. A circuit inside the TV selects only the station you want to watch and splits the signal for this station into separate audio and video information, passing each to a separate circuit for further processing. The electron gun circuit uses the video part of the signal to recreate the picture filmed by the TV camera. The circuit fires 3 electrical guns down a cathode ray tube, like a fat bottle from which the air has been removed. The electron beams pass through a ring of electromagnetics. Electrons can be steered by magnets because they have a negative electrical charge. The electromagnets steer the electron beams so they sweep back and forth across the screen line by line. The electron beams pass through a grid of holes called a mask, which directs them so they hit exact places on the screen. When the beams hit the phosphors on the screen, they make red, blue or green dots. Elsewhere, the screen remains dark. The pattern of red, blue and green dots builds up a colored picture very quickly. Audio information from the incoming signal passes to a separate circuit. The audio circuit drives the loudspeaker so they recreate the sound exactly in time with the moving picture.
The broadcast of a television picture begins with a television camera. Inside most cameras, a prism system breaks light from a scene into the 3 primary colors of light: red, green, and blue. The colored light falls on image sensors called charge-coupled devices, or CCD, in the antenna. Inside the TV, the tuner selects the desired broadcast signal. Other parts of the receiver separate the audio signal and send it to a speaker system. The video signal is divided into 3 signals, one for red, one for blue, and one for green. The inside of the TV screen is coated with stripes or dots of red, green, and blue materials called phosphors. An electron gun for each color shoots an electron beam onto the screen, line by line, which causes the phosphors to glow. The beam's strength, which is controlled by the video signal, determines how brightly the phosphors glow. The patterns of light given off by the phosphors duplicate the image recorded by the camera, and the viewer sees a picture of the original scene.
This is a screen capture from the Physics 2000 website. You can see a cathode ray tube here in its simplest form, and I'm going to modulate the electron beam by increasing the voltage at the grid in the electron gun. The more voltage I apply, the more electrons head to the front of the tube, creating more light. With a complex picture, the light intensity is constantly changing at high speed. Here's a more complex version of a cathode ray picture tube. Magnets are able to move the electron beam around, since electrons are attracted and repelled by magnetism. I'm also modulating the electron beam with the brightness voltage, so you can see a sort of picture forming on the screen. Here's the complete version of a cathode ray picture tube. There are coils of wire on the neck of the tube, and when those coils are energized by electricity in the form of sawtooth waves, they move the electron beam around. Because there are two sets of coils, one set moves the beam horizontally and the other one moves it vertically, resulting in a rectangular pattern that fills the screen.
Antenna. Antenna is a vital component of any communication system which is used at both transmitting end as well as receiving end. Antenna is basically a conversion device and is made up of a long conductor. At the transmitting end, it converts electrical energy into electromagnetic waves and then radiates into free space. At the receiving end, it receives electromagnetic waves and then transforms them into electrical signal which acts as input for receiver. Antennas are basically of two types: dipole antenna and dish antenna. Dipole antenna is omnidirectional and used in the transmission of radio waves, whereas a dish antenna is a directional antenna used typically in radars and satellite communication.